Good morning, my YouTube viewers. It is Crystal here, and I wanted to make another video for you. And this video is going to be about statistics because I don't know if you're aware of this, but statistics predates machine learning, and a lot of the functions and methodologies that are in machine learning were actually in statistics before they were in machine learning. So basically, when you study statistics, you'll notice that a lot of the functions in statistics are also in machine learning. And so what I wanted to do in this video is I wanted to compare linear discriminant analysis to logistic regression. So linear discriminant analysis is a classifier, but it works on boundaries, whereas logistic regression is a classifier as well, but it works on percentages. And so what I wanted to do is I wanted to make sure that I'm running up a data set in both logistic regression and linear discriminant analysis, so you can see how these two models differ. And so if you're going to use linear discriminant analysis, it's best to try it out with another model as well, so you can pick out the best model. So what I've done is I've used a data set that I got off of sklearn, and it's called CodeType. It's a new data set because I don't go into sklearn data sets that much anymore, but this one is a really big data set. It's got like 500,000 rows of data, and because it's got so many rows of data, it will take a long time to go through all that data. So what I did, in order to make it a little bit easier to work with and to run more quickly, I just made the data smaller, made the rows of data smaller. So rather than having 500,000 rows of data, there's only going to be about 5,000 and something rows of data. But it still gives you the general idea of what's going on with the data set and the program. It's just you're just not using all of the data, because it would just take too long a time to try to run this data on logistic regression and linear discriminant analysis. So the first thing that we're going to do in this program is we're going to import the libraries that we're going to use to execute the program. So we're going to import pandas as PD, which we're going to use to process the data. We're going to import numpy as NP, which we're going to use to perform numerical computations. We're going to import sklearn, which is our machine learning library, and it gives you machine learning functionality. We're going to import matplotlib and seaborn, which is our visualization libraries. So after we've done that, then what we're going to do is we're going to want to load the data set. And I got this data set off of sklearn website. So it says from sklearn.datasets import fetch _ CodeType. And this data set has something to do with soil and roadways and things like that. I don't know a lot about it, but I picked it out because it is a classifier. It's a data set that has classifiers on it. So CodeType equals fetch _ CodeType brackets random state equals 42, as frame equals true, return xy equals false. So we're going to view all columns of data pd.set_option brackets display.max columns, comma, none. And then we're going to view the frame, covetype.frame. So you can see we can view all of it. And you've got 581,012 rows of data, and you've got 55 columns. So well, you can view all the columns of data, and you can see it's a lot of data to view, but the very last column of data is your target, which gives you your cover type. So as I said, I don't know a lot about this data set, but I wanted to use it because just to demonstrate logistic regression and linear discriminant analysis. So we're going to check information about this data frame, and you can see all of the columns of data are floats except for the end column of data, which is the target, which is an integer, and that's going to be your categories. So we're going to check for null values, and we don't have any null values. So we're going to make the data set smaller for testing purposes because it was such a large data set. It would take forever for it to get through the logistic regression. So covetype small equals covetype.frame.sample brackets frac equals 0.01 comma random state equals 42, and then we check the shape, and so you've got 5,810 rows of data and 55 columns. So now we're going to analyze the target. We're going to create a histogram using Matplotlib. And when we created our histogram using Matplotlib, you can see 1 and 2 have the highest degree of frequencies. So 1 and 2 are the two highest numbers. And then 3, 4, 5, 6, and 7, they have a small amount of numbers. So this is letting you know that it's also an imbalanced data set because you've got 1 and 2 have lots of information, whereas 3, 4, 5, 6, and 7 don't have very much. So it's an imbalanced data set. So we're going to check our dependent and independent variables. So y equals covetype small, cover type, and x equals covetype small dot drop cover type, axis equals 1. So y is your target, and x is everything else, all of the other columns. So now what we're going to do is we're going to create a heat map. So core equals x dot core, sns dot heat map, brackets core, comma, annotate equals false, comma, cmap equals coalworm. And then we've got a title as correlation heat map, and we show it. So you can see here on the heat map that most of the columns of data are not very highly correlated at all. The highest correlation is going to be on round, and it doesn't even show. There's so many columns of data that it's actually more difficult to see what the highest correlation is. But you can see that you can use, if you wanted to, you could employ feature selection to remove the lowly correlated columns of data and see how that worked out. But I didn't do that. I just created a heat map. But most of them are not highly correlated at all. But you can employ feature selection. But if you employ feature selection, then you also take the chance that your accuracy is going to be lower. And you can also remove the highly correlated columns of data as well if you want to. But anytime you employ feature selection techniques, you always run the risk of your accuracy being lower. So now what we're going to do is we're going to split the data into training and testing sets, and we're going to use sklearn's train test split. And the train data set is going to be 80%, and the test data set is going to be 20%. So now we have our logistic regression model. So LR equals logistic regression. And I said solver equals SAG, class weight equals balance, random state equals 42. And then it said max IDERs equals 10,000. And dot fit X train, Y train. Print the accuracy. You have an accuracy of only 50%. So you can see that logistic regression hasn't performed very well with this data set. Then we predict on the test set. And when we predict on the test set, again, you have an accuracy of 50%. And you've got your confusion matrix. So your confusion matrix will tell you which ones you got right and which ones you got wrong. So we're going to plot this in a basic histogram. And you can see that 3, 4, 5, 6, and 7, you can see that it selected more 3, 4, 5, 6, and 7 than is representative of the target. But that's what it did. It didn't do a great job, but that's what it did. Now we're going to check linear discriminant analysis. But before I do that, I want to do one thing. Because I don't need that there. Now we're going to check linear discriminant analysis. So LDA equals linear discriminant analysis. Brackets solver equals SVD. Brackets fit X train, Y train. And then we're going to print the accuracy. You've got an accuracy of 68. Then we're going to test, make predictions on the test set. And it's going to be an accuracy of 66. So you can see the accuracy using linear discriminant analysis is higher than logistic regression. And then we've got our confusion matrix, so you can see which ones are correct and which ones were incorrect. And then we're going to plot a histogram, and you can see that when we plot the histogram, it looks a little bit more representative of what it looked like when we ran the target. So here's another one we've got here. And this one is just classify students as pass or fail. And so we've got linear discriminant analysis. And when we ran the linear discriminant analysis, we had an accuracy of 1. But when we tried it with logistic regression, we also had an accuracy of 1. And the thing is that's why I didn't really want to go over it. Because I thought, well, it's not going to do a lot of good if you have an accuracy of 1 in linear discriminant analysis and logistic regression. And the reason for that is because you're not really demonstrating the difference when you do that. So I had another one like lone default. Again, on the lone default for logistic regression, you had an accuracy of 67%. And for linear discriminant analysis, you had an accuracy of 67% as well. So that's why I didn't want to use this, because I didn't want to use data that's going to give you the same value on logistic regression and linear discriminant analysis, because that's not really showing you the difference between the two models when you do that. And so that's why I picked this model out of sklearn to use. So that's it for this video. I hope that I've been able to demonstrate to you the difference between linear discriminant analysis and logistic regression. If you like my video, please like and subscribe. And I look forward to making another video for you in the very near future as I carry out my research.